much, Brian, for introducing us, and thank you all for coming. We are so happy to introduce you to our activity. Today, we'd like to share you about the P4 Stratum use case for new edge cloud. Today, we have presentation by Masa, and I will present from two perspectives from NTT groups. I belong to NTT East, which is residential network operator, and I'm in charge of plant planning, designing production network, and drawing future network service strategy. Let me give you a little bit of background about Japanese market. We provide last mile FTTH service to majority of Japan. Total number of subscribers we serve around 12 million. This slide shows high-level view of our current network. Thousands of subscribers are aggregated by an edge router at each central office, and those edge routers are aggregated by tens of core routers at the regional office. It's typical access aggregation topology, what you can imagine. Customers can build closed network between enterprise branch office just using our NGN, or use our services directly served inside NGN. At this network, SDN has been partially deployed as a part of NFV service infrastructure, but thousands of legacy routers are in operation. So far, it has been working well, and we have had FTTH coverage over 99% for a couple of years. Anyone in Japan has freedom to enjoy FTTH service at wherever they desire. This chart is from a bit old source, but as you can see, the fiber infrastructure has already been widely deployed for quite a while in Japan. In the context of deploying new architecture and technologies such as SDN, the maturity and track record of existing legacy can get in the way, making people to hesitate changing things. And brownfield migration is always a hard task to tackle. However, depending on how you see it, there is an upside for the network to be old. Network change is inevitable due to network element reaching end of life and become unavailable from vendors. This is just my opinion. I feel this could be a great opportunity to start evolving. What is anticipation for new network? As you all may have heard in various conferences, communication service providers today are under pressure to reduce costs due to exponentially growing traffic, while number of subscribers are almost saturating. Shaving down costs, applying automation, and optimizing use of resources is a must, but pure cost reduction is not beneficial in the long term for the entire ecosystem, and not so fun at all. So we need to explore way to create new services adding values to customers to avoid becoming cost cutter providing downpipe again. There are various areas to explore in terms of improving our networks. Many of the items I'm sure you have heard from other operators as well, sort of global trends. By the way, as a consumer of services, many industry provides absolutely incredible services in Japan. One example, there was a case Japanese railroad operator had to apologize for missing schedule by just 25 seconds. Japanese customer base really demanding, and their baseline expectation high. Same expectation apply to us network operators. So it can really be challenging to try new things. But at the same time, Japanese customers like to try and come up with new things. Whether you guys like it or not, we Japanese came up with emojis. Also, Japanese vendor was the first to deliver production open flow switches, as you know. They showed us the path for us to explore SDN journey, but that's another story. Anyway, if we could come up with something interesting, there might be a room for adoption. And I believe open source and programmable data plane could potentially play a role there. Naturally, we got interested in P4, Stratum, and UPAN. This slide shows the overview of them. As you know, ONF operators and vendors lead these projects, and we anticipate all of projects working together will form foundation of leveraging programmable data planes. And we have just got started tackling with white box switches and programmable ASICs in our labs. We intend to evaluate flowing 2 use cases using P4-enabled data plane switches to explore service benefits and business opportunities. One is video streaming to explore something new P4 can do. And the other one is P4 feature swapping to see how programmable devices can help legacy service migration or so. We'll look into each of them in next slides. First, live streaming use case is about improving viewers' experiences. Typically, live streaming today is implemented in a way that streaming server up in clouds reflect back the source stream back to clients. It travels through all the way through our network, top to bottom, and adding delays. This can be a problem, especially in a stadium event type of scenarios. What we intend to explore is to use P4 switches at edge router to offload video live streaming protocol handling to improve viewer experiences. Instead of going all the way up to the streaming server and back, and instead copy the stream back to clients requesting for the multicast feed at edge routers, which we hope will reduce traffic hitting our networks and at the same time improve user experiences. This is fairly generic diagram, not specific to live streaming offloading, but what we hope to get out of P4 switches rich packet transformation capability dealing with large number of sessions at full line rate. We can imagine various applications by using such an architectures. The second use case is about feature swapping. One of the challenge we have is that we have various purpose-built special hardware for legacy services. Even we do now expect growth in those services, we need to have stock supplies in place to maintain service continuity. This introduces complexities in hardware investment planning and field deployment logistics. We hope for P4 programmable switches to become the generic pieces of hardware, which can be transformed into a network device for serving legacy and new features by installing software and profiles, making hardware resources planning simpler. This slide is just for your information sharing as an activity utilizing our edge presence. To today audience, it might be easier to describe as concept code is exploring, leveraging our central offices as place to host third-party services. We have started providing edge cloud computing platform in few locations to explore its possibilities.
Hi everyone. I'm Masa in NTT, and I'm in charge of service design of service edge platforms for next generation edge routers. So this slide shows again. I'm in NTT, so I'm tightly coupling working with NTT East about this project. So this slide shows our current networks and future networks concept and architectures. The left side is, as Jiro said, our current engineering networks architectures. And this is basically for, what I can say, for the customer services networks. So we offered triple play services such as broadband access and voice services and video services. But now NTT is transforming our business models. So we are wholesaling our networks, and we offer various values with several service business partners. So we think we have to change our networks more flexible and scalable. So, and NTT R&D activities also very put a high importance on open community activities. So that's why I'm here in today. So because various innovations happens in open source communities like ONF or so. So it's very important to work and collaborate to many partners and staff members. So back to the topics and about VLGs. As we said, I'm focusing on service edge platform, so it's very important how we change BNG for the next generation architectures. There's no alternatives but to choose dedicated edge routers for now. So, but if we make our networks more flexible and scalable, we disaggregate BNG functions with using code servers and ONF and white box switches and Stratum such as compact hardwares. So, but so far it's very difficult to disaggregate BNG functions because, as Deutsche Telekom says, BNG has a much kind of functional. So it's very difficult to put these kind of functions to the VNF and white box switches because we need much performance to replace current BNG routers. So it's difficult to do so. But now we can use new network programmability technologies such as programmable ASICs and P4s and etc. So we can break through these situations. So I don't think I have to I talk about P4 and Stratum because many of you always know these kind of words. So P4 and P4 runtimes makes our networks more flexible. So that's why we are talking about these technologies. Yes. And next, I'd like to talk about our use cases and route trials. So in our laboratories, we are trying to do two kinds of lab testing. One is how disaggregate BNG, control plane, and UPAN functions. And the other one is to make a platform for ultra-low latency services using in-band network telemetry functions. This is the first use case. So in this slide shows we disaggregate various functions into C-plane and U-planes, and we put U-plane functions on the switches, and so implement and C-plane functions on the common servers using virtual functions. So this is a rough diagrams. In our networks, we use PPPoE and L2TP terminations. So upper side is virtual BNG provide C-plane and U data plane functions. But we use P4 on the switches to implement data plane function to encapsulate PPPoE and L2TP tunnels. We don't have enough time to evaluate from today, so we're just evaluating lab testing. But by using this kind of switches, we can get enough performances. If we use virtual loaders, we can get such kind of performances. So in that means that works out so well. The next use case is inbound network telemetry. I don't need to explain inbound network telemetry. So let me skip this slide. So this is also the last basic test of inbound network telemetries. So we can confirm that we can find hop-by-hop latencies by implementing inbound network telemetry functions on switches, as well as end-to-end latencies. Yes. And last month, NTT held the annual exceptions, NTT R&D Forums, and so we demonstrated these kind of two trials at the exceptions. Here is the photos last month. Yes. And in these trials, Barefoot and Aprecia support us very well. So Aprecia is a Japanese switch vendors and white box switch distributors. We totally works them well. Yes. Okay. This is the conclusions. I think network programmability is a key component to realize the edge cloud platforms. So, and we confirmed P4 is a strong possibilities to support our use cases to our lab test. But there is some hurdles to overcome, and especially I think it will be important how we can integrate data plane function with control planes. We tried the simple lab tests, but if we work to the commercial levels, how we integrate these kind of functions is very important. So next step, we don't evaluate Stratums so far, but we have expectations to support people in Stratum. So we are going to evaluate Stratums the next step. This is the last of our presentations. Thank you for listening.